Hello everyone. So in this video, we will simplify this log expression. Now as per the problem, we have to use the laws of log to rewrite the following in terms of log of x to the base a, log of y to the base a, log of z to the base a. Now here we are given a single log term with this fraction. So we just have to expand this expression. So for that we'll use the different laws of log. So the first step here is to break up the single log term of this fraction into two log terms using the quotient law of log. So I'll write the quotient law on the board. So log of m over n to the base x can be written as log of m to the base x minus log of n to the base x. So the base of the log terms stay the same. Instead of writing it as a fraction, we subtract these two log terms. So we will use this law here to first break up this fraction into two log terms. Base a and x to the power 4, y to the power 1 over 2 minus log of base a and then the fourth root of z cube. So basically the denominator expression goes in the second log term. Now we have to split up this first log term using the product law of log. So I'll write the product law on the board. So as per the product law, so log of m times n to the base x can be written as log of m to the base x plus log of n to the base x. So the base of the log terms is the same and we add these log terms. So we'll use the same law here. So I will break up the first term into two log terms. So log of x to the power 4 base a plus log of y to the power half base a, and then the third term minus log of the fourth root of z cube to the base a. Now since we have to write the expression in terms of log of x to the base a, log of y to the base a, log of z to the base a, we have to get rid of the exponents on x, y and z in these three terms. So for that we will use the power law of log. So I'll write the power law on the board. So as per the power law of log, so log of base a and then b exponent c can be written as c log of b to the base a. So the exponent c becomes the coefficient of this log term. So if we use this power law for this expression, so for the first term, so we can move the 4 from the exponent to the coefficient. So the first term becomes, so 4 log x to the base a. Now we can do the same thing for the y term. So the exponent half becomes the coefficient, so it becomes half log of y base a. Now in the third term, in the z term, so the first step here is to convert this radical into a rational exponent, and that will be log of z to the power 3, and then the fourth root becomes the rational exponent 1 over 4 and the same base a. Now we can simplify the z term further. Now for the x and the y terms we cannot do anything, so they stay the same. So 4 log of x to the base a plus half of log of y to the base a. Now here we'll have to use a law of exponents to combine 3 and 1 over 4. So we have to use the power on a power law. So that means we have to multiply the powers. So we have to do 3 times 1 over 4, which is equal to 3 over 4. So when we do 3 times 1 over 4, so we know the denominator of the 3 is 1. And when we multiply fractions, we multiply the numerator terms, 3 times 1, which is 3. And the denominator term is 1 times 4, which is 4. So we can just move a step here. And I can use a different color now. The x and the y terms stay the same. Plus 1 over 2 log of y base a. And now for the z term, we can use the power law of log. So the exponent on the z becomes the coefficient of the log term. So it becomes minus 3 over 4 log of z to the base a. So this should be the final answer for the given expression in terms of log of x to base a, log of y to base a, and log of z to base a. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.